All right, welcome back, guys. Hopefully you did pretty well on this page. Again, this is all supposed to be a review, so I'm not going to spend a ton of time teaching this material because this is stuff that you're supposed to know really coming from either Algebra 1 or from the previous sections in this book, okay? So I'm going to kind of walk through them, some of them quicker than others. We're going to start with number one. Number one is a literal equation, meaning that you have basically you're solving, your answer is going to have letters left in it. So you're not getting like x equals 5. You're getting x equals like s plus p or something like that. So let's work this one. Keep in mind backwards PEMDAS, okay? If you look at number one, it says it wants to solve for s. So the first thing I want to kind of bring your attention to, this is s right here, so that's what we're wanting to get by itself. What I'm going to do is I'm going to ask myself what is being done to s, and that's the stuff I'm going to undo. So it's being multiplied by 1/3 r, the opposite of which is division. It's also being, they're adding q, okay? And so we're going to deal with the stuff inside the parentheses last. Don't forget that. Don't try to add q, right, or don't try to get rid of the q first. We want to get rid of the 1/3, we want to get rid of the r, and then we want to get rid of the q, and we'll get our answer. So first thing I'm going to do is get rid of the 1/3. I can either divide by 1/3, or I'm actually just going to multiply by 3 on both sides. So I'm going to get 3p equals r times q plus s. My next step is I want to get rid of the r, so I'm going to divide by r. So I get 3p over r equals q plus s. Notice once everything is gone outside the parentheses on that side, the parentheses go away. And so my last step is going to be to subtract the q. So I get 3p divided by r minus q equal to s. And that's my final answer. And that's why it's slightly different, because we don't get some magical s is 7. Okay? This just lets us know that if we knew what p was, we knew what r was, and we knew what q was, then we could solve for s. Okay, so that's number one. Number two, there's a whole list of shapes there. Just want to run through the names really quick. The first one is a square pyramid or a rectangular pyramid. I'm going to go with square pyramid here. It just kind of, to me, it looks like they're trying to give the impression they're the same lengths, but rectangular pyramid would work as well. Maybe even be a better name for it, given that we don't know exactly the side lengths. The second one, B, is a cylinder. Okay, with cylinders and cones, you don't have to add in what the bases are because they're automatically going to be circles. The next one is a two-dimensional shape called a pentagon because it has 5 sides. D is going to be a cone. All right. E is an octagon, another two-dimensional shape. And the last one is a rectangular prism. Rectangular prism. I know you might see a box, but in geometry we call that a rectangular prism because the base would be a rectangle. Okay. Hopefully that makes sense. We're good there. Let's talk about 3 and 4. I wanted to go ahead and work 3 and 4 out with you. So I recopied them here. The key to 3 and 4 is going to be the similarity statement that they give you. They tell you that A, B, and C is similar to X, Y, and Z. That means that angle A is going to be similar to angle Z. Remember, the letters are going to have to match up. Okay, and hopefully that will help you visualize. Notice A and C, so first letter, last letter, versus Z and X, first letter, last letter. That means these two sides are going to be similar to each other. And notice we multiplied times 3, so there's kind of a times 3 factor going on here. All right. So what number 3 asks us, if you look at it, it says, hey, find the measures of A and X. Well, if we know that it's times 3 to get from this one to this one, right? So 8 times 3 is 24. What number do we multiply times 3 to get 27? A is going to be 9. Okay, because 9 times 3 would give us 27. All right. And then what is 5 times 3? X is going to be 15. Hopefully you got that. Hopefully that makes sense. All right. But that is similarity statements. Make sure you're good with that. The next thing in number 4 asks is, hey, which angles are going to go together? It says name the pairs of angles that are congruent. And so you can use this statement to know which angles go together. So angle A is going to be congruent to angle Z. Angle B is going to be congruent to angle Y. And angle C is congruent to angle X. And they did that on purpose. Notice this is ABC, then XYZ. They did it on purpose just to make sure you were paying attention, to see if they could catch you slipping up a little bit. All right? Number 5. Number 5 is talking about a circle. And they tell us that a circle has a circumference of 15 pi, and they want us to find the area of that circle. So what we need to remember is that the area is going to be equal to pi r squared. So in order to find the area, we need to find the radius. So what we're going to do is we're going to take these two and set them equal to each other. So we have 2 pi r is equal to 15 pi. And then we're going to solve for radius. So we're going to divide by 2 pi. Our pi's are going to cancel, and our radius is going to be equal to 7.5. Okay? So now we're going to take that value, and we're going to plug it right back into the formula for area. The formula for area is pi r squared, so we're going to have area equals pi times 7.5 squared. Okay? Pi times 7.5 squared. And just in case you don't know, 7.5 squared is 56.25. So our area is going to be 56.25 pi. Okay? You can multiply it out, but there's no reason to. That is a good enough answer there. Okay? In fact, in terms of pi is what we would call that, and I think that's the best answer because it's not rounded. Number 6. Number 6 gives us a square that they've cut a circle out of, and they want to know the shaded region. So for me, whenever I look at composite figures like this, in particular when they're taking something away, I like to kind of draw a picture for myself to remind myself what I'm doing. And so number 6, really what they're asking us for is, hey, what is the area of the square minus the circle? Okay? And so really all we need to do is plug in the lengths or the values that they give us. They tell us that the units for the square, that the side lengths are 8. Okay? Which tells us that our radius, think about it, if the whole thing is 8, if the diameter is 8, our radius is 4, okay? So that means I'm going to have 8 squared minus 2 pi times, oh, bad teacher, not 2 pi r. Whoa, look at that. Almost made a mistake there. So it's going to be s squared minus pi r squared, okay? Because remember, pi r squared is for area. So we're going to have 8 squared minus pi times 4 squared. So in reality, we have 64 minus 16 pi, okay? And that is going to be our exact answer. That is in terms of pi. And notice that's what they ask for in 6. They don't ask for the decimal. Stay away from the calculator. They want this answer, okay? And yes, that's as pretty as it gets. You cannot take 16 pi away from 64 because they're different things. You treat, whenever you have that pi in terms of pi, you treat it almost like you would an x. It doesn't really relate with the other stuff, okay? Number 7. Number 7, we have a composite figure. 7 and 8 are based on the figure that's on the graph. Number 7 asks us for, hey, what are the names of the shapes and the formulas involved in finding the area? So I'm just going to go from top down. First one is a triangle. And then, of course, what is the area formula for a triangle? A equals 1/2 base times height, okay? Or base times height divided by 2. 1/2 base times height is probably the more common way you'll see it. Next shape we have is a trapezoid. Trapezoid. And the area formula for that one is a little long. It's 1/2 B1 plus B2 times H, where this is B1, this is B2, and the H is perpendicular to the bases, and that would be our H, okay? So those are the measures you would need to find the area of a trapezoid. Next shape we have a rectangle, okay? Rectangle or parallelogram really would work the same way. I'm going to put rectangle on here though, rectangle. All right. Now, I know a lot of you learn length times width for a rectangle, and that is perfectly fine. I'm going to write base times height just so it kind of matches up with a lot of our other area formulas. We get used to the idea that the base is on the bottom and the height is perpendicular. So I'm going to write base times height, but length times width will work there as well. And then for number 8, I think it's too easy, so I'm not going to work it. I just want to make sure that you verify that you got 60 as an answer. All you're going to do is find the area of the triangle, the area of the trapezoid, and the area of the rectangle, and then combine those together, okay? Hopefully this was an easy page for you. We'll see you back here shortly when you get ready to do activity 30, which is what comes next in the book, all right? Thanks, guys.